This lesson is going to focus on the meaning, or revisit, in fact, the meaning of improper fractions and mixed numbers. And what we're going to be able to do by the end of the lesson, hopefully, is convert mixed numbers to improper fractions and vice versa, convert improper fractions to mixed numbers. Here's a bit of a starter activity. This was a NAPLAN question a few years ago that many students got wrong. Helen has 24 red apples, 12 green apples. What fraction of the apples are green? So what many students did for this one is they saw 12 green apples out of the 24 apples, said the answer was a half. Not correct. Let's try to visualize this. All right, now how many apples has she got in total? She has 24 red and 12 green. That means that she's got 36 apples in total, of which we've got 12 green and 24 red. So 12 green apples, what fraction of the apples are green? It's 12 out of the 36 apples that we've got in total, which if we divide by 12 and divide by 12 to simplify the fraction is the same as 1/3. The correct answer was 1/3, B. Which of the following are mixed numbers? Well, mixed numbers have a whole number part and a fraction part. That's a mixed number. That is an improper fraction that can be converted to a mixed number. That is a proper fraction. That's also a proper fraction, and that's a mixed fraction. Convert the following mixed numbers to improper fractions. So this one here, what we're going to note is that 5 3/4 is exactly the same as 20 quarters. That's what 5 is. 5 is 20 quarters. Okay, if I've got 5 of something, I can also say I have had 20 quarters. Consider a netball tournament, and if you in total play 20 quarters for that day, that would be the equivalent of 5 full games. Okay, so that's 20 quarters plus an additional 3/4, which is the same as 23 quarters. But an easier way of doing it is the more algorithmic approach. What you do is you multiply 5 by 4 and then add 3 to the result. So let's do that first of all. 5 times 4 is 20 plus 3 is 23. You write down that number there and your fraction still has the same number of parts. That's 23 on 4. You'll note that that's exactly the same answer. With this one, let's do the same thing. 3 is the same as 18 parts on 6 plus 5 parts on 6, which is 23 parts on 6. We can do that algorithmically by going 3 times 6 plus 5. 3 6s are 18, plus 5 is 23, over the same number of parts, in this case is 6, 23 on 6. Again, notice that we got the same answer there, albeit a bit quicker with the algorithm. Girls, we can also convert improper fractions to mixed numbers, and you've kind of done this already this year. 9 over 4 is the same as putting 4 into 9, or splitting 9 into 4 parts. Right, well, how many times does 4 go into 9? It goes in there twice, remainder 1. Now, how were we writing that earlier this year? What we were saying is that 2 remainder 1 means that we've got 2 whole times, 1 left over, and what we were doing was splitting that 1 into quarters. So we use the same approach to this. We go and think 4 goes into 9 2 times. We've got 1 left over, and what we're doing is we're splitting that remainder into 4 parts. So 10 on 3, what we're going to do is put 3 into 10 and say that that goes 3 times. We've got 1 left over, and what we're attempting to do is split it into 3 parts. If you can't visualize that, that's no problem. Try it with short division and see if you can visualize it with that method. All right, we've got 12 on 3. So 3 goes into 12 4 times. We've got 0 left over, and we're splitting nothing into 3 parts. And yep, you guessed it. The answer is just 4, because if I've got, or I split something into 3 parts and take none of it, I've got none of it. Okay, a cake that's split into 3 parts and I take no parts of it means that I've got no cake. Therefore, the answer to this one is just 4. Okay, here we go with a couple of additional questions here. And if you try question 3 out, this is a pretty good question. The shaded rectangle represents 3/4. Here is our shaded rectangle. What's the value of the entire large red square? So many students see an object and they say that it equals 1. Well, who told you it's equal to 1? Okay, and in fact, let's just see what it is equal to. So if that's 3/4, then that's going to be 3/4, and that's going to be 3/4, and that's going to be 3/4, and that's going to be 3/4, that's going to be 3/4, that's going to be 3/4, and that's going to be 3/4. Now, how many quarters have I got in total? I've got 12 quarters here and 12 quarters here. I've got in total 24 quarters. Now, 24 quarters is exactly the same as 6. This shape is actually, this red shape here is worth 6.